Good afternoon, everyone. Welcome.
Good afternoon.
So I'm going to need
Good
everyone to
afternoon.
have the training computers turned on. Let me know if you have any issues on that. I can sort you out. As we were going to do some practical examples during this course. So let me know if there are any issues on your side. All right. Well, I'm going to go into introductions here. So my name is Gabriel. I'm going to be your instructor for today, and I would like to welcome all of you to the Kepware Fundamentals Overview module. So this is your basically your introduction into the Kepware world. In this course, we're gonna discuss a bit about the landscape of industries in the manufacturing industries, and I'm going to introduce you to the ISA 95 framework that is being used to describe this environment. And finally, I'm going to introduce you to the Kepware server interface application. So we're going to see how it's being used in this industry. How can we connect to devices? What does it do to bridge this gap between IT and operation technology? So it's a very basic class. Even if you had no prior experience in Kepware, worry not that this class is fairly simple, even for the very beginner. As we see here, we have no prerequisites for this class. All right, before we get into it, I would like to describe how I like to do things in my classrooms. So since there is a full class today, feel free to use the chat, the Teams chat at any time to ask me questions or any type of discussions. I will check the chat regularly and answer the questions in due time. If you want to ask me a direct question using the microphones, just so we don't talk over one another, I would please ask you to use the raise hand feature in Teams. This way I can see like, hey, someone raised a hand, wants to ask a question. I can make like a short pause in my presentation. So in this way, we don't speak over one another. Just like like a live classroom would behave. You have your presenter in a live audience and you raise your hand. We're going to try to simulate that here also. Okay. Also, please use the React emotes, like thumbs up, all those lovely reactions there, just to let me know that you're here, that everything made sense. Like if you have some problems with some of the exercises, again, you can use those thumbs up there, like, hey, yeah, all good, we can move forward. So let's discuss a bit about these manufacturing environments that we operate in. Okay, it's important we set the stage before we actually jump into Kepware, just so you have like a background explanation on this. I'm sure most of you already operate in one of these manufacturing environments. I'm just going to outline them. I'm going to give you some examples, and then we're going to look at how Kepware fits into all of this. So basically, we've categorized these industries into three main groups. So we have like a discrete manufacturing industry, a batch, and a continuous. Yeah. So in the discrete, what does it mean? This is like in this manufacturing environment, you have the assembly of components that will in the end make up a final product. Okay, so individual components, like you have car parts. Okay, for automotive industry, you have car parts or planes. Again, you build individual parts, and then will be assembled to make up an entire product. Laptops, same thing. Batches, just like the name says, it's basically a process that makes products in lots, in batches. Not in a continuous stream. It uses a specific recipe with a specific volume, and they bring ingredients together to form like a batch of products. So food and beverage falls into this category here. And in the continuous industry, well, yes, this flows in a continuous stream, and it creates a final product in a non-stop production cycle. Petroleum refineries, power plants, water plants, all of these that operate in a continuous cycle. So all of these groups use the energy and raw materials to create something, but they operate very differently. So although they are pretty similar, they do have some different parts to them. For example, every manufacturing type that we've outlined here has its own terminology. They all come with their own specific equipment, they all have their own specific machines and different data integration and challenges. So we're going to learn just a bit about the terminology here and the equipment that they're using, just to get better. So although they are pretty similar, they into these industries. So I'm just going to give you an example here, again, just to get a bit deeper into it. There are some use cases here about each of these industries. For example, the discrete, just like I've explained in the beginning, you have like an assembly of components that makes up a product. So the main equipment used here, as you can see on my slide, like cutting machines, CNC machines, welders. And the main challenges in this industry is basically what? Quality, right? And the way quality, the KPIs are calculated in this industry includes like, okay, how many defects will you get per 1,000,000 parts? Usually you get a number there, and that's how they calculate usually the KPIs here. Also, elimination of waste is also a value here, a benefit, which is focuses on. And now, let's do a small recap of what we've just discussed. So I'm going to launch a poll on your screens, which will follow a question here. So all you need to do is just answer on that pop-up you're going to get on your screens here. So which two types of factories would be considered in the discrete manufacturing environment? And you can put your selection in there. Okay, the poll will only stay active for a little while, so please have your responses ready. Don't worry, these responses are anonymous. So I'm not going to point the finger at anyone for getting it wrong. Okay, poll ending in 3 seconds. And you should be able to see the final results in the chat as well. So the majority, actually everyone, 100% response rate said B and E. And that is perfectly correct. Yeah. So smartphones and airplanes, they all fall into this discrete manufacturing environment. Very well. So we've looked at some of the similarities. Again, this is a table here that outlines distinct differences between all of these 3 different industries. Yeah, just so you get like an overview, like what is the equipment being used into each of these industries. You see the data integration varies also, not only on specific industry, but also varies among different vendors, because there are several vendors providing data integration into each of these industries. The challenges also are quite similar, like producing a product that meets quality standards and eliminating waste. However, you know, a challenge in the continuous manufacturing environment, for example, is more closely related to, okay, how do we keep this running nonstop with no downtime? So obviously the focus here is just running this long term, minimizing the amount of downtime. That's another challenge there. You see the controllers that we see in a continuous compared to discrete and batch usually are RTUs, and you work in a SCADA and telemetry. So this just gives you a overview here. Right. So now that I give you some background insight here, we're going to discuss next about this ISA 95 framework. So this will be like a bigger section I have to dive into. Probably some of you already know what it is. Maybe some of you don't, and you have not interacted with this terminology. No worries, because I'm going to explain and we're going to cover this in detail. So basically, the ISA 95 framework brings in this disparate manufacturing industries, brings them together. We're going to discuss about similarities here. So what's the ISA 95? The official definition, how would you look at it, is a framework that provides terminology that is considered to be a foundation for application functionality and how information is to be used. So that's like the official definition. So it provides consistent data integration and terminology. So we're gonna go into it a bit here, how it actually works. So this is how we term the traditional data flow within this standard of ISA 95. So yeah, so remember, we have all the assets, we have the controllers and the sensor that you find in a manufacturing environment. But in addition to the physical assets, there is also a standard software in these factories. So that's where ISA 95 helps us organize this landscape. To make it simple, basically, guys, it doesn't matter which industry you're coming from. Everyone will be using the same terminology operating within this framework. Yeah, that's what it does. Yeah, it brings everything together into a single terminology. All these different clients, all these different industries will talk in the same way. So you can see that it runs on levels. It starts from level 0, which is the actual physical production process. This is where your machines are. This is your raw materials that will make up your product. On level 1, you have your controllers, the logic, yeah, that runs the inputs. So level 1 basically focuses on what? On the PLCs, right? As we go to level 2, you have the monitoring control. This is monitoring the processes, usually using HMIs. Yeah. As we get into level 3 to operations management, this is where we talk about software like MES, yeah, that schedules production, assures reliability. And finally, level 4 is for business planning. Yeah, and this spans in a wide area, business management, like the types of material used, the providers, delivery, shipping, costs. So this is the enterprise level, basically, yeah. And here is where you see software such as ERP, yeah, enterprise resource planning being used. Now, when you look at these levels, traditionally, how it works in this framework is that information is being exchanged from level to level. It never skips a level, yeah. So if a client, an MES client from level 3 wants the data from the production floor, that data will pass first to level 2. And what does level 2 do? Level 2 has a different set of objectives than level 3. Yeah. So that means that level 2 will take that raw data, it will format it to fit their needs, and then once they're done with that, it will be sent upwards to the next level. The problem is that data is not as useful for the operations in that formatted in that way. So you see, that's a bit of a problem here. So this is where Kepware will come in to solve some of these issues here, which we're going to discuss in the next section here. Where does Kepware fit into all of this? Okay, time for a knowledge check question here again. This time, this is a single choice question, so it's rather easy. Just recapping, what is this ISA 95? Okay, let's see the results. Okay, we have a 90% response to the correct question. Yes, that's B. Okay, standard that provides consistent terminology as a foundation for manufacturers. Very well, that's 90% correct. So let's talk about Kepware now, finally, right? Where does Kepware fit in? So remember, in the traditional ISA 95, information goes like a staircase. Yeah, if you look at these levels, it looks like a staircase. You just have to climb from level to level, floor to floor. Now, Kepware server comes in, and what Kepware does, it turns this this method, it turns it a bit upside down, because Kepware can now enable communications from the production, from the factory floor, where the assets and controllers are, directly to the level it needs within the framework. So it doesn't operate outside of the ISA 95, it operates within, but a bit tilted. So you can think of Kepware here like an elevator. It takes the information from level 1, wherever it's being asked from. So this way, the upper levels like 3 and 4 will not receive that data formatted. They'll receive it raw, and then they can format it on their own specific needs. Unlike relying from biased data from the previous levels. Yeah, does it make sense? This is how it works in this industrial IoT model. So the levels still exist, though. Don't think that just with the introduction of IIoT that these levels disappear. They're still there. It's just that Kepware can see them all into one bucket. Yeah, Kepware sees them, all of these 3 levels, into one bucket, so it can just send that data to whoever is asking for it. And this begs the question: does the way information is being communicated in this IoT still complies with the ISA 95 traditional communication standards, true or false? For this question, guys, you can just give me here in this poll a thumbs up or thumbs down. So thumbs up for true, thumbs down for false. So it doesn't say if it operates within the ISA 95. It says if it's following its standard protocol on the way information flows. It's a bit tricky the way it's spelled, the way this question is being asked. Okay, let's see the responses on this one. All right, so this was interesting. So you all can see the result here. So we have 7 answers for true and 2 for false. Well, now, why is this true though? Let's recap a bit. Maybe we just went a bit too fast here. So in ISA 95, what's the workflow? The traditional way. Information goes level to level. In IIoT, information skips level. So IIoT does not follow the communication standard imposed by the ISA 95, which says, hey, information goes level to level. It does not comply with that. However, it still operates within the framework. I mean, the levels, like I said, the levels still exist. It just doesn't follow this communication standard here. So that would mean that this question is actually false. Okay, it does not actually comply with the communication standard. Like I said, this it's a bit weirdly phrased, but that's the answer here. Let me know if it makes sense to you. Okay, moving on. So now we're just reviewing a bit the role of each of these clients on each of these levels, just to give you some perspective here. Like I said, Kepware, the Kepware server views all these applications in levels 2, 3, and 4 into one bucket. Yeah, it doesn't see them on different levels. You just see them all there. But traditionally speaking, each level has a distinct purpose that it solves. Yeah. Like I said, level 2 is process supervision, which deals with mainly HMIs and SCADA you see on this level here. This is the type of applications. In operations management, this includes the MES or MRP. So this is not the product focused level. This is actually used to track the entire progress. Like when you build an automobile, it tracks the progress of the entire automobile, not the individual parts that will make up the final automobile. Yeah. So the MES system is responsible here for sending the work instructions or recipes, the set points to the PLCs. And the business systems, this includes mainly the ERP. However, it can also include the PLM. Okay, so product lifecycle management, or even the CRM, which is customer relationships. So here, basically, the manufacturing data we get is basically integrated with business data. Yeah, gives you like an overview of an entire business. So this includes finances, obviously, right? So the costs, the cost of the entire business, accounting, the personnel, the customers, you know. So all the stakeholders, basically, this gives you an overview of all the stakeholders. So we've talked about, we've used these terms here, so we're just trying to make sure there's no confusion between these two terms, process data and production data, and where they're being used on different levels. So the distinction is that when we say process data, this is typically the raw real-time data that comes from the equipment on the plant floors. Whereas production data, it means the aggregated information, which is basically the process data combined with measurements or other filters that makes up a summary of information. Okay, so that's the main difference here. So the process data basically is the raw one. It's not manipulated in any way before it reaches level 2. It's also the real-time data. This goes here. The real-time things that are happening on the plant floor. And usually production data is what we use to calculate the KPIs. We make calculations with it, business calculations. OEE also. And there's a couple of knowledge check questions coming next, just to see if we've got this section right. And afterwards, we can jump a bit and introduce Kepware into the equation here. For this question, guys, you can type in the chat which level will primarily deal with the production data. So the production data. Which level or levels, maybe? Very good, Daniel. Yeah, I see everyone. Yeah, Anna, same. You're all right, guys. Some of you just said L3, some L4. Yes, it's actually both. So both of these upper levels deals with production data. Yeah, they actually need to massage that process data for their own specific calculations. Okay, and that's where calculations are being made, the business calculations, level 3s and 4. So very good on this one. And here, this one again, this is self-explanatory. The process data is being handled at level 2. This goes without saying. So here comes the Kepware and its client connections. So Kepware is here in the middle. You can think of Kepware like a general server model. That's how it works, basically. So, like I said, Kepware still operates within the ISA 95 with all those levels. However, it sees all these different clients on the same level. Yeah. Not only that, Kepware can connect to different devices at the same time. So we have all these different various devices that Kepware communicates to. It uses its drivers to communicate with devices. We're going to go into a device communication a bit later. And then it can send this data to multiple clients simultaneously. And here you have all these different levels calling this data. You have level 4 here, a level 2 here, level 3 here, and they're all of the same. And they can get that data simultaneously from these devices. So we're going to talk about next, how does Kepware do this? So how does it communicate? So basically Kepware, actually, before we get into Kepware, the clients and the devices themselves have specific communication protocols. Now, if you look at the client side, the most popular communication protocols are basically OPC. So the OPC Foundation, the classic specifications of OPC. If you're not aware about the OPC Foundation and the classic specifications, worry not. Another class in this Kepware series will focus entirely on OPC connectivity. So you will be introduced to all these terms, which might be seem a bit new to you. And then we have the REST communication protocol, which in theory actually is not a communication protocol because it uses HTTP as the protocol, but hey, details. And we have MQTT and always on, which is a proprietary protocol used by ThingWorx, our other product from PTC. And all of them come with security implemented, all of them. With its own security layers. Like OPC has its own security features, like digital certificates. Yeah, the keys, they use keys with digital certificates. Kepware also can use the self-signed certificate to authenticate with an application. Also, REST and MQTT allows for user authentication, the manual, the classic authentication, and even encryption. So all of these have their own security implemented. Now, looking at the device protocols, device communication is not usually encrypted. That's the problem here. Because this can be an issue on a factory floor, in the factory, yeah? So we should try to restrict access to outside networks as much as possible. So most PLCs and PACs use unencrypted communication, yeah? And that's something, one of the challenges that we will have to solve here. So security is basically not a feature for communication being done here at the device levels. So from 0 to 1 to 2, basically you don't have any security protocol here in the manufacturing zone, we call it. So you have to take your own measures here to implement security within your factory. And there are some steps you can do to, we're going to outline here a few of them that you can deploy. For example, you can create like a demilitarized zone. Usually this is what it's done traditionally, a DMZ it's called. So this acts like a buffer between the enterprise systems and the manufacturing zone. So basically you have like a firewall on each of these sides here, like that. You have enforced user authorization between these sides, and even separate VLANs distribute the data here. So again, you should validate also the network traffic that travels through your switches and routers using some port security or something. Also, you have to establish domains of trust. Try to segment your network into like smaller areas, yeah, with access, with different access there. So these are just some, this is not a security class, oriented class, but these are just some basics here that you might want to check out. Also, where does Kepware fit into all of this? Basically, Kepware has a place in both of these tiers here. So you have the first tier of Kepware is where your clients or anything that's outside of your intranet will communicate. So that's here. And then everything inside of your intranet, where the information is being gathered. So Kepware server, like I said, operates within this DMZ. So it can be used to transmit information from the manufacturing zone into the DMZ here safely. So this will establish a secure communication between your plant and the enterprise. So all information that travels here should be authenticated and encrypted, especially here on this side. So whenever it travels from the DMZ to the enterprise, you should enforce some sort of authentication, authorization, and encryption. Anyway, if you want to read more about the DMZ, it has a support section I've listed here in the slide. So you can actually read more on this section here. So if you just search for this in the ANSI 990201 2009 section 83.3.4.2, and you can read more about network segments and zones here. All right, guys. Now, we've just covered a big section in this introductory class. So what I would propose here, guys, just to just to refresh a bit, just have a quick cup of coffee or something. I suggest here a 5-minute break, just a bio break here before we jump and talk into how Kepware connects to all these different devices and vendors using these drivers. So I'm going to introduce you next to the actual Kepware interface. We're going to go a bit into the interface. And in sections 4 and 5, we're going to deal with this device communication and connectivity. We're actually going to do some fun exercises in section 5 here with some simulated devices. So I would propose a 5-minute quick break here. So I'm going to put a timer on a screen, and just so you know when everyone should come back, when this timer hits 0. Okay, so I'll see you all soon. All right, so we're all back. Let's continue here. So we're going to talk about what's a driver in Kepware. So basically the drivers are the main power in Kepware. And that's how Kepware can talk and communicate with all these various vendors using specific protocols, also known as languages. So different languages of communication. So Kepler uses these drivers, and we have lots of them. We have approximately drivers that cover over 150 protocols available. So we have a various amount of them, a wealth of drivers. So Kepler can connect to OPC servers, different PLCs, different computers, databases, and sensors. All the configuration settings for all of these protocols will be similar. So don't think that each specific device or vendor has a very different configuration that you have to learn. It's pretty similar, not the same though. There are some drivers which require some sort of a different settings and have a different network interface. However, they're all protocol specific. Like for example, we have the Modbus protocol. There you have some options where you can define the number of registers being transmitted into a packet of information. Anyway, we're going to learn more about individual device protocols in connecting with devices module, which is another class in this series. So how would you define a driver? Again, I'm going to put the answers, the response box on your screens. Just a second. So what's the role of a driver? Just so we're on the same page. Let's see some answers, guys. There's like 13 of us, and I only see like 7 or 8 answers per question. I would like to see more activity in these knowledge check questions. So let's get at least 9 responses. Come on. Okay. Okay, poll ending in 3 seconds. All right. Now that's what I like to see. More activity, 10 answers and 100% on the jackpot, basically. Yeah. So that's B. Correct. A driver's specific purpose is only to communicate with devices. However, there are some cases there where drivers are being used to communicate with OPC servers, for example, or it can act like an MQTT subscriber. But yeah, I'm just I'm just going to too nuanced in this discussion. So that's what you need to remember here. So I'm going to show you in Kepware where you can find these drivers, and also I can show you where can we find the individual information about each protocol. Here on my slide, I only have a few of them to show you, but I'm going to show you in the actual interface the rest of them. Yeah, these are the most popular ones that we use. The Modbus, for example, this is developed by Schneider Electric. It's an open protocol used by manufacturers in many industries, especially in Europe. It's a protocol that allows serial or Ethernet transmissions. It's a very easy protocol. Then we have also the Allen Bradley, developed by Rockwell. And again, this is a big one. and is mainly used in the United States. And one of the most popular drivers we use in Kepware is the Allen Bradley ControlLogix Ethernet driver, which supports many different devices that we're gonna discuss more in another course. And finally, we have the Siemens. As we know, the Siemens is a German company and very popular in automation and industrial plants, used across Europe, especially in Europe. And there are a few others here that they're covered here. Now, let me show you in the actual interface that we're going to finally jump into the virtual computer. I'm going to show you where you can see all of these drivers. So I'm going to launch the Kepware interface. You can do the same on your computer, guys, if you're curious to navigate through the interface. I'm going to explain the interface in a second. Now, I'm just going to do a short demonstration just to show you where these drivers are. So when you attempt to create a new channel, we're going to discuss about these channels. This is where you can see the full list of Kepware drivers. Like I said, over 150 protocols are covered with these drivers. So if you want to learn like specific information about each driver and you want to see what are the supported devices that work with this driver, how do you set up its interface, because they all have like specific interfaces, you can click on this question mark here. This is a very important button. Whenever you see this button, it takes you to the help file in Kepware, which is a very, very stuffy place here. So let me make it a bit bigger. Very useful thing here. So yeah, of course, we have like the help file for Kepware in general about the Kepware interface, like how to set up channels, how to so my mouse just stalled. Oh, my mouse battery died. Okay, that's great. Okay, I have to use the laptop for this one. Okay, so excuse me if I run a bit slower. My battery just died on the mouse. All right. So I want to show you here that online also on top of the help file for individual Kepware, we also have individual help files for each of our drivers. Here, you can see on the list. Now, these are not Kepware specific help files. They are actually from the manufacturer, from the vendor. So if I go in the Modbus, for example, it launches the actual manufacturer's details here. Of course, it's in the Kepware interface, but these are coming from the manufacturer. And you can learn more about it, like, okay, what's the Modbus Ethernet driver, okay? How do you configure a channel and device to use with this driver, you know? We have here the setup. Let's see. Again, I'm working a bit slower. I'll change this battery out at the next break though, so. Okay, here are the basics of the driver properties and advanced settings. So all the settings that you have to cover when you set up this driver, you're gonna find here. This is how you point to the ID of a device. For example, you see this protocol uses specific ID address to contact a device, a specific IP address. So you can see what this IP address consists of. So it has the original IP address where the device is physically located, followed by this Modbus bridge index, which is from 0 to 255. This is specific to Modbus. That's why we have these help files. Yeah, you can see what's the block sizes that you set in the Modbus driver. Yeah. But yeah, I'm not going to go too much into detail now, since we have a whole class dedicated to set up these device properties. But I'm just showing you where you can fish for the information you need. So anywhere you click on that help button, it takes you to this this file here, which is a server help file, but also individual drivers help file. Or you can just search for the information you want to find. There's some useful links here as well. Takes you to a Kepware website or our support center. All right. Really have to change this battery. Another useful little driver we have. This is a bit more specific. The Yukon. This driver actually it's here to enable users to create a device driver, either for serial or Ethernet devices that don't have an off-the-shelf driver available. So this includes like small devices like the one in the image here, like a barcode reader, various sensors, or even RTUs. So it has like a very simple interface, even for a non-programmer user, that you can use to create a driver for these devices to get this device started and connected. So it's a very can be a useful driver, this one. Now we're going to go next into the actual connectivity with the devices. So we're going to, in this section, we're going to actually connect a device with the Kepware. So we're going to get some hands-on experience using Kepware. We're going to see how we establish this communication with a device. So this is what what we're actually waiting for, right? So you see here, this is the actual, basically the definition of Kepware on the left. And what I like to name Kepware is like a universal translator, I like to call it. Yeah, because that's what it does. It deciphers and translates all these various different protocols into a protocol that can be consumed by a client application, like an OPC client, right? So let's go one by one through the things that you have to create and go through the Kepware interface to enable communication. So we always start with a channel, which we're going to go now and start creating. So we need to create a channel. First, the channel is where you pick the driver. The channel is where you choose what protocol are you going to use to communicate with your device. So this is where you pick like the Modbus or Allen Bradley. So what is the device you're connecting to? Then the next object is the device object after you create. This is where you indicate the actual IP address of the physical device, the location of the device where you're going to connect to. And also there are some other settings you set up there about their tags, like scan rate and such. The next object is the tag. This is the last thing. Tags is basically the tags you want to access from the device. Yeah, tags are data points in the PLC, in the memory address space of the PLC. That's what data tags are. So a client that connects to Kepware is able to access this tag and read them through Kepware. Now, usually there is a person who programs the PLC and writes these tags in specific address spaces, not at random, right? Usually all these devices have a CSV file provided with these addresses and their names. So these tags will contain the data that your client application is actually looking for. Okay. Now, let me do a quick tour now of Kepware, just show you where you can find everything. So this is the interface, and as you've probably seen, this interface is made up of 3 sections. So this left section where you see this tree view, this is called the project tree. Yeah, the project tree view. Now, as you can see, there is only one single project entity in this spot here. Yeah, meaning you can only have one project file instance running per Kepware server at once. So you cannot have these multiple projects created and running at the same time. Only one per Kepware. Under connectivity, we find the devices, usually all the different devices which are currently communicating to Kepware. So this is where you create your protocols and connection to the devices under connectivity. Yeah, channels are basically those communication threads which are open. Yeah, so each channel is a different communication thread. I mean, you can see the dotted line here that goes through Kepware. And inside the channel, you have your actual device. It doesn't have to be one device, guys. It can be multiple devices. So you can have multiple devices connected in a single thread, in a single channel, or you can have multiple channels with single devices. And then what comes after, these are advanced plugins. Basically, except advanced tags and aliases, which are some specific stuff, all of these are clients, connections to clients. Yeah, we're going to discuss about these. These are called like native interfaces, native client interfaces. So you have client connections here. So in this course, we're going to make a quick, easy connection to a device, but the details behind these connections will be covered in the next courses. So each of our following courses will address a different connectivity aspect of Kepware. Yeah, we're going to go through some of the plugins in other courses like IoT Gateway, advanced tags, data loggers, but not in this class. This is just an introductory course here. So let's create our first thread of communication. So we're actually going to connect to a simulated device that we have. It's a Modbus device that we're connecting to. So everyone, let's follow along. First things first, we create a channel, so you can right click on this connectivity part here and say new channel. And we said we're going to connect to a Modbus. So we're going to use a Modbus Ethernet driver. You can type on your keyboard for Modbus and search it here. So I'm looking for the driver Modbus TCP/IP Ethernet. And then you have to give a name to your channel here. I like to say like something very specific like Modbus channel. Yeah, you can put something like that. We're gonna keep the settings defaulted for this one. We're not gonna change anything here. Okay, and you have our first channel. Okay, give me a thumbs up in the chat when you're done creating the channel. Okay. Next, we have the device. You can just click here under the channel, click to add a device, or here on the right. Yeah, it doesn't matter where you click. And you can just name it, I don't know, device one. And how I like to put it, I like to shorten the name because I have a less of an overhead. I'm just going to use D1. So D1. And what we're going to change here is the IP address. So we're going to use the actual address to point to our actual device that we have connected to. So we have to put the following here: 10.0.0.47 or 7, you know. And guys, we're not gonna play with the settings for this one here. So we're gonna keep everything at a default value here. So just press next, next, next. Okay. I'm not gonna change anything yet. All good here? Okay, and the third object is the actual data tags that we want to read from the device. So we're just going to point to some address spaces at random in this device. Okay, so we're going to create the tags manually. There are other ways to create tags, like we can import them, we can automatically generate them from a CSV file. But in this case, we're going to manually name the address spaces ourselves and see if we get anything into them. So we're going to click the D1 device here, and we're going to say create a new tag. Let's give it a basic name like T1 or tag1, whatever. You just pick a name, but make sure you increment it. So you put 1. There will be incremented. So you can browse the current available addresses. If you go to this address here in data properties, you can actually see the address syntax here present on this device. So this is the syntax. So we could use, I'm going to use some not random figures here. Let's say address space 4000 and 1. So that actually 40,001. I'm just going to put something like that. And I'm going to say OK. Now I want more of these tags just so we can get something happening here. So what I can do to save time so I don't have to go and create an individual tag, I can select this tag and I can say here duplicate tag. There's a button here in the toolbar called duplicate. So create 10 of these tags, guys, using the duplicate button. Yeah, just click it and you're going to have like 10 tags. You see they're automatically incremented also here, but also in the address space in the registers here. Now, how can we check? Did anyone raise their hand? I just saw a hand there.
Yes, Gabriel. Could you please show once again like how you created the first tag?
The first tag?
Yeah.
Well, there's several ways. You just click on the device and there's a button here in the toolbar that says new tag, or you can right click on this D1, which gives you again the same option, new tag.
Okay, got it. Thanks.
And you just give it a name like tag1 or T1, and you put the address space 40,001,
Sure. Thank you so much.
and then duplicate it. Now, how can we check if we're actually connected to this device at all, and if we're actually receiving data from this device? Can we do that in Kepware directly? The answer is no. So Kepware is unable to make device calls to read tags. That's the responsibility of a client. So only the clients can connect to Kepware and request a read from a device. So the client tells Kepware, hey, I want this tag being read, and I want it every 1,000 milliseconds. Establishes the scan rate. So Kepware itself, you see, I cannot see the value of this tag in Kepware. I cannot see if I'm getting any values anywhere. However, we have something here. There is a little tool in Kepware. It's right this icon here on the far right in the toolbar. It's called the Quick Client. The Quick Client is basically a client emulator, an OPC-DA client to be more exact. So this client simulates a client connection to Kepware. And this way we can actually make a device reads or writes, just like a client would do. So we're going to open the Quick Client, and we see we can browse the Kepware channels on the left here. So let's go to our Modbus channel, D1. So Modbus channel D1. I'm going to make this bigger a bit. And have a look. Some of these tags are static, but some of them update. They have like a function to it. So you should be able to see the same result here. Please confirm if you do or you do not. Okay. Another interesting thing here is that we can make tag writes. We can actually write in the address space of this device. And funny enough, since we're all connected with our Kepwares to the same device, we're all able to make modifications to this device. So basically, I can go in let's say tag 1, and I can make a synchronous write. I'm going to put a value 123. And if you guys check your tag 1, you should see the value 123 there. And you can do the same thing. Yeah, I'm already seeing someone is making modifications there. Yeah. So you guys can modify these tags, and we can all see it at the same time in real time. We can see these updates. Even if you have another tag name, the address space is the same. So we're all reading and in real time from this device. Fun, right? Yeah. Play around. All right. When you exit the Quick Client, make sure you say, yeah, don't save changes. You just exit. You close the connection. So this is a simple example of a connection to a device. This is how it will look like to a real device. Now, let me do like a quick run through this whole process again, just to make sure that everyone understood how it works. So I'm going to use a nice little metaphor that we have here in my PowerPoint slides. It's a fun metaphor here. It's called the road metaphor. We like to compare these connections to devices like a road, a highway. So we think of the channel as the road, the path you're going to take to your device. So we have like different highways, Highway Express 1, Highway A2, or the Modbus highway, because we want to reach to a Modbus device. So we're going to take our car, which is our client, Kepware here. I don't know, this was supposed to be a car, but I'm using my mouse, my tab on the laptop, so it's terrible. Anyway, so we're going to pick a Modbus road and we're going to travel to it. Okay, next. When you want to reach a destination on a highway, you need to know the exact, okay, road number, I would say, right? The address. So that's the next step. Finding the actual object we're looking for. This is the device. So that's why when we set up a device, we have to set the actual IP address of this physical or simulated device to point to it. So like as we're driving through the highway to try to find our device, we need to know exactly at which kilometer we should stop and pull over and get to the building that we want to reach. So we can think of the device like a building. Next, once we reach the building here, we need to get to certain floor and certain apartment, right? So we need to get to floor 1, apartment 6. So see how specific I am. That's how memory address spaces works for tags. You access a specific tag address, just like accessing a specific floor and finding a specific room. Yeah, so the tag, think of the tags like rooms in the building, in the device, the address spaces. So me, the client, now I'm going to access those rooms that I need. And that's how it works, basically, this metaphor. Like if it made sense, I hope it did. Yeah, you get to the rooms of the device and you fetch the information you need from the rooms or the tags. Made sense here? If you have any questions regarding this process of connection or establishing the channel, device, or tags, let me know. Otherwise, we can proceed. So if there are any confusion regarding this here, about this process. Pretty self-explanatory, right? It's pretty logical. Okay, we're gonna get into the section 5, which, like I said, it's a very practical session. So we're gonna use our simulator drivers, and we're gonna actually simulate connection to devices, and we're gonna get the data from them, and we can see how we can make some manipulations to this data. What would be the use cases of using device simulators? And we're gonna check all the device simulators available for us in Kepware. There's 3 of them. So we're gonna look at all 3 of them. Now, I'm gonna take this moment here to pass another 5-minute, 7-minute bio break, and I can use this to change my battery on my mouse, because as you've seen, I make terrible drawings with the laptop pad, so I'm gonna go change the battery. So I'm gonna give you another small break here, and this will be the last one for today. Okay, because it's just excruciating working with the. Okay, let's give it a 6-minute this time. We're gonna increment the break. Okay, guys, see you very soon. Hey, everyone back? Okay, we're in the final stretch here. So let's crack our knuckles and get started here because we have some practical examples in section 5. We're going to review some device connections and simulations. So we have like 3 types of simulators available. 2 of them we're going to explore in more depth as we're going to do exercise with them. However, there is also a third way that you can simulate data in Kepware. So the main simulators we have available in Kepware is the advanced simulator, the simulator driver, and a memory-based simulator driver. So all of these are drivers, basically. Yeah. And the first 2 will be explored in depth. Now, my question to you guys would be, why would we want to simulate data in the first place? Why couldn't we just connect our hook up our client to the devices? What would be a need for a simulator? Just bouncing some ideas here. Yeah, so testing could be a use case here. What kind of testing? Would you like to test the device or test their client? Exactly. Yeah, very good there. So we use this type of simulators, guys, for testing the actual client. So a scenario might be, so you have your client and you've written some logic in your client, logic that triggers on only when the data that comes in behaves in a certain way or reaches a certain threshold. Sometimes triggering these some scenarios are very rare, so it requires specific data manipulation. So this way we can simulate unique scenarios to debug our client. So we can trigger these events happening, the logic that we write. Yeah, just so to test and see if it's behaving how it's supposed to. So that will be a one very important use case there. Before we get into the actual simulator drivers, I have to show you here that each device has in the device properties, I'm going to show you now in the interface in a second. All devices have a simulated option. By default is no. But if you set it to yes, if you had a real communication to the device, the server and the device will cease communication. It will zero out the data in the cache, and all reads and writes from the client will be sent to the cache, but will not go to the actual device. Let me show you. So let's say I have my Modbus device. It's a real connection, right? So if I go to device properties here, you see all the devices have a simulated property here called simulated. So this is using valid OPC data without actually communicating with the physical device. So doing so will stop the connection between my client and this Modbus device. Yeah. So you see, I'm having no data here. So if I want to test, I can create some tags here that some random function tags, we're going to get into those, that we can use to simulate and test this client that I'm connecting here. just so we don't use the actual real data there. As we set this back to no, everything will operate back as usual. So the communication with the device is reestablished. The cache data is being wiped out with the one it was captured during the simulation, and it will be replaced with the actual device data. Yeah, so we're going to go back to normal, and we can read the device back to normal. That's a quick way just to disconnect the device and use some sort of own functions there. Now let's get into the actual drivers. So these are quite interesting. We have two very different types of drivers for simulating data. Let's talk about the advanced simulator. This one is acts in a particular way because what it does, it plays that data back stored in a database through an ODBC connection. So each column of data will populate a tag value. Each column we have in that table on that database. And the data change will be happening at the interval we determine. Now, this ODBC data source can either be an actual SQL database, or if we can even use CSV files. So you can, for example, do an export in a CSV, or you can create one using Excel, and you can create your own custom data there that will trigger certain scenarios, and you can plug this in and connect your client with this advanced simulator. So we're going to do an example with the latter, the CSV file. We're not going to connect our SQL. We do have an SQL database, but we're not in this course though. Now, to actually use this driver, we're going to have to define a data source configuration. So we have to set up a DSN, data source name, and we're going to see how we do it. We can do it directly in the Kepware interface. Let's go first things first. Let's create our channel for this CSV simulator. So I'm going to go to connectivity and create a new channel like I would to a device here. We're going to choose, it's right here at the top, the advanced simulator driver. Let's name this channel CSV sim. Yeah, just pick something smart there. Okay, we're going to create the channel. We're not going to modify anything. However, once we reach this step, you see we have to provide a data source. So we have to if we don't have one, we have to configure one. Obviously, we don't have one. So we're going to click on the ellipsis here. This is where you select your ODBC data source. But we have none. So we're going to say, okay, let's set up a new one. So we're going to say configure DSN. So it will launch the ODBC data source administrator here. This is a Windows interface. Now, Kepware, we're going to discuss this in another course, but Kepware is a system service, not a user service. So we have to select here in the tab system data source. We have to create a system data source. Otherwise, it won't work. So select system DSN and say add. We said we're going to use a CSV file as our data source, so we can choose the driver here to Microsoft text driver. You see it accepts text files and CSVs. So use the text driver. Let's give it a name. Text DSN would be a smart name here. This is exercise 2. I'm just gonna give it a random description here. Now we have to point to the actual DS source. Yeah, we're not gonna say use current directory because this is the default directory. We're gonna uncheck this current directory, and we have to select manually the location where our CSV file is. Before we go here, let me show you where it actually is. So we can actually investigate it for a second. Let's go to the File Explorer for a second. Open the File Explorer. And go to this PC, local disk W. In this big list of folders here, we're going to look for a folder called TWKS -over, as in overview, lab file. So TWKS over. Find this folder, open it. And in here we have the CSV file that we're going to use for our simulator. We can open it and we can have a look how it's been made. We can say open with Notepad. And you can see we have 2 columns, amps and volts, with 9 data entries for each. That's all. This is all the data source we have for this example. Okay, so we have 2 columns, 2 headers with 9 rows of data. Okay. Just wanted to show you where it is and what it is. Okay, now going back to my ODBC text setup here, we're going to say select directory. So now, guys, we simply just have to find the same directory folder, the same path. So make sure to change the drive to W. So it's local disk W here. It's a pretty sketchy interface here, but hey, we're going to try to make do. Find the same folder, TWKS. So KS, yeah, make sure it's KS. We have 2 types of folders like this. KS over lab files. So open it. And it will automatically already draw this CSV file. See it here in the left. And we're going to say, yeah, okay. We've pointed to the directory. Now we're going to go to options for a little bit. And we want to define the format for this table, basically. So obviously, we're going to select the table called device draw. And we want to implement a column name header. So this will be set to true. We want to take the column name headers, and then we're going to say guess. Basically, it tells the system, hey, guess your columns, right? And yeah, we get the amps and volts. And it guessed the data type as well, as you can see, which is float. Well, I'm satisfied with this result here. So I'm going to say, OK. This message is no issue here. So if you see this error, just say OK and ignore it. It doesn't, it's irrelevant for our situation here. And OK again. And you should see your data source here created. And by the way, guys, you only do this once. Like, if you have already a data source, defined in the system, you can reuse this across other scenarios. Like if you have an actual data source connected to an SQL, You don't need to create every single time a new data source name when you have to use it. So unless you want to read from a different table or you want to change some settings there, then you can create a new DSN. Okay, now we get back to this data source selection. We have the text DSN here selected. We're going to say OK. We have this selected. We don't have a username and password for this data source. So we're going to go next and finish. Okay, is everyone following me so far? Let me know if you're behind, or if you're stuck somewhere. Okay, I see someone has a question. I see your hand there. Let me know what's if you have any issues.
Yeah, actually, I got stuck on the second point. I'm not able to select the Excel file, the CSV file.
In that setup there, right?
Yeah.
Well, Siddharth, I can visit your VM, and
No,
I'm
no,
able to.
like I'm lagging behind with, I'm not right now coordinating with you. I'm
That's
just
fine.
trying to, yeah,
That's fine. I can help you, so I can help you
sure,
catch up.
sure.
So I'll assume control of your training computer. Actually, I've put your computer on share screen here. So if you have any compromising tabs open, you should close them. Okay, just joking on that.
Yeah,
I'm only able to
understood.
see the the virtual machine, not the computer. Okay, so you're in the right place. You don't need to select; it's already selected. See, so this
Okay,
device draw. You just need to say OK, and then you have to format it a bit. So we're gonna say here define format. Now you select the actual table,
yeah,
and you're gonna guess the columns, and you should get amps and volts, which is exactly what we want. Oh, you didn't get any errors there. I got an error. Oh, you already had the one created. Okay. Okay. Well, it still works. I think you went to configure here for a second. That's why. Okay. Text DSN. Well, should be working.
okay,
We're gonna see.
thanks.
No worries. Anyone else having issues here? All right. Okay. Next step. Create the device. Right. That's the next object. We're not actually creating a device since this is a simulator. What it does is we're basically creating a placeholder for our simulated table, the CSV file, right? So still, we're going to say create device. I'm going to name this CSV because it's not an actual device. And now it asks us, what is the table you want to attach to this device? So now we should have here our device draw table that we have from the CSV file, right? And so we're going to say, yeah, we're going to pick that table. Now, in here, we can select, it actually says here, specify the interval in which the driver will automatically jump to the next record in the table. So how often will it browse through those records? We only have like 9 records, so I'm going to go with a much slower rate, like 2000 milliseconds. Much slower, so we actually get some time to see what's going on there. And the second option here is if you would like to When you reach the last record in the table, loop it from the beginning, yes or no? Yeah, we're gonna say yeah because it's only 9 entries, so it will browse very fast through them. Okay, we say next and okay. And you see the tags were generated automatically in my device. They're automatically generated from the table, from the columns that we have in the table. So each column has its own tag value. Okay. Let's test it using the quick line. So let's look what we're actually getting into this simulator. So CSV sim, CSV device. This one should be the one. So you see, it respects the scan rate that we've set of 2 seconds. And what it does, it just browses through those rows of data from the CSV file. And we can read it. And again, you can manipulate that CSV in an Excel any way you like to give you back the data that you specifically want to trigger something in the client. Or you can do this from a database table. Okay, anyone has any issues here?
Yeah, hi Gabriel. Actually, I am facing some issue. Could you please help?
Go ahead. Let me know what happened.
Uh, I mean, it says unable to retrieve table names. Reason Microsoft ODBC driver manager.
Hmm. Okay, so you ran into some issue at the setup there. Well, I'll have to actually have to go and check your machine and see what did we got there. Driver manager. Okay. Driver issue. Okay, so there was a problem in the actual setup here. Why do we have a password here? Should be any password. Okay, data source sim1 dsn. Let's have a look here. Microsoft text driver. Ah, so the reason you got that is because it didn't detect any tables in this DSN. Why? Because you have not specified the directory where to look for tables. You see, it's
Okay.
using the default directory. So you have to specify again the path. I see it is specified now.
Yeah.
Okay, so we select where the folder that contains my table.
Okay.
Then we go and format it the way we like. So we have this here, amps and volts. Looks good. Okay, well, it looks fine until now. So the directory is specified now.
Okay.
Okay, now let's check again. There we go.
Hmm.
Now it can actually see the table. It was not specified in the directory there, so
Okay.
that's all.
Maybe I missed something. I did like it was already configured, but maybe I don't know what happened.
Yeah, I think maybe you didn't select the
or something.
directory there or save to that directory where the table is located. So the system could not find any tables to generate for this device. Yeah, you just missed a step there, nothing serious.
Gotcha.
So you see you now generated the tags, amps and volts here. And open your quick client and go to the actual device and you should see the table entries just update.
Sure.
Right. That's about the simulator. This one is a much more fun, in my opinion. The simulator driver. So it's a big difference between this one and the advanced simulator. This one allows us to actually create a virtual device with registers that we can program with constant or function defined data. We can actually define what's the size of the register address space, like if it's an 8-bit device or 16-bit. And basically this driver, it simulates a PLC. So we can actually program our own virtual PLC and then connect it to Kepware. So that's why this one is fun, because we can see how we can program a PLC also. Well, just a part of writing in the address spaces of a PLC, in the memory address space. So to index into the register, we have to use the addressing scheme of the device, which is usually a letter followed by a number, like K0002, right? R1195. Another method would be to use a dynamically moving data using a simulation function. So you see here in the example below, this is a simulation, this address. We have several of these simulators. I'm going to show you in the next slide. So the letters, the K, R, B, S stands for constant. Yeah, Boolean is B, string is S, ramping is R. Ramping, it just means that it increments the register value by 1 at each read. And then we have the functions. You can put functions into your virtual device, which simulates dynamic data. And we have several formulas, 4 of them, that you can use. For example, let's take the random function. Actually, all these functions, you see the first parameter is the rate. This is the rate as defined by the OPC Foundation. So it indicates the time period between the data changes in milliseconds. So if I put a random function with a rate of 200, comma, the low limit, let's say low limit is 1, comma, high limit 10. How do you translate this simulation? Can someone tell me? How will this simulation work? It will do what?
It will give us a random number between 1 and 10, uh, changing every, like with the frequency of 200 milliseconds.
Yeah, 200 milliseconds. So every time it will generate a random number in these values as we set in the rate here. Yeah, so that's pretty much it. Yeah. Ramping is type of an incrementing number, so it increments. And you can put the increment like every 10 units, 100 units, or whatever you like the increment to be. So all of these functions are doing this particular thing. Okay. So let's create this simulator. We're going to play around. So it's different. We don't need a data source or anything. So we're just going to create a new channel. And we're going to use the simulator. So look for the simulator driver here. It's called simulator. Let's give it a name to this channel. Let's call this simulator. Simulator. And keep everything defaulted here. You also have the option to persist these address contents, but we're not going to do that. Exercise 3. Okay. Now let's create a device. I'm going to call this Sim1. Oh, what was that? Oops. Sim1 device. You can choose the model of the device. It's an 8-bit or 16-bit. Let's make it an 8-bit for fun. Okay, we're going to keep defaults here. And now we can define and write our own addresses in this device like it would be on a PLC. So we can decide whatever we want to create here. So let's create a static tag. So I'm just going to name this static tag. And I'm going to put a constant number, yeah? 1000 and 1. And then I'm going to create another one. Let's create a different one. Let's create a ramping tag. So that will be an R. Again, you can say here whatever number you want, like 4001. We can select a data type if you'd like. You know, like let's say it's a word. Word. And finally, let's add a simulator, a simulation function, a dynamic function. Let's add random tag, just like the random we've talked about. So we're going to say here random in the address space. We're going to open the brackets. We're going to specify the scan rate. Let's say 2000 milliseconds. No, actually, let's say less. Let's say 1000 milliseconds every second. And we're going to increment from 0 to 100. Okay. And this will be, let's say, I don't know, also a word. Or it can be a float. Okay, I think it's enough enough tags. Let's test. Let's open the quick line. Let's go to simulator channel, sim1. And there goes our tags. I could set this even slower. Let's say 2000 milliseconds. You see this one updates slower than my ramping tag. This ramping tag goes every second. This one goes every 2 seconds because I've specified the scan rate. And this is an empty tag because it's a constant. However, I think you can write to it. Yeah, so we can make a write to this static tag. Pretty simple. Also, guys, just know that we have a place here in Kepware. You see there's a channel here called Simulation Examples. So if you plan on creating these simulators and you want to create certain functions just for testing, you have some preset functions here, guys. There's like 8 different types of functions for each example. Actually, these ones only have 4. And you have in the description here what they do. Yeah, this value decrements, increments, random between this number and this number. Everyone has a different type update rates. Sequential float values, sequential Boolean values. So again, you can use some of these functions. All you have to do to use them, you can just here. I'm gonna say this and this. I can do copy, and I can use them in my simulator here, for example. Just paste them, and now I have them in my my driver here, in my device. All right. So you can make use of those simulation functions there. Or create your own. Another consideration on this topic, guys, is the data types. You've seen as we're playing around with the tags that you have many different data types available there in Kepware. I've outlined here in my slide the most common ones that we find. Now, what's the thing with these data types? Notice their sizes. They take different sizes in the register spaces of devices. Now, that can be a problem. Why? Let's take this a conflict, for example. We can have conflicts in the actual register addresses as we write to register addresses. So let's look here. We have 2 ramping functions on register addresses 1001, 1002. This is an 8-bit device. So this 8-bit device has 8 bits per register. However, a word, this is a word data type. A word data type has 16 bits in size. So these 2 will have a conflict. So this data will be overwritten here. So let's take an example and let's create a conflict just so you see how we can react in cases like this. Guys, I think we should just delete all these tags here just so we make some room. Yeah, just delete all the tags in the sim1 here. We're gonna create new ones. Let's create a ramp1 function, which is written on the address space. Let's say just like the slide says, let's say 1001. Let's make sure it's a word data type. And to create the second one, guys, you can say duplicate, just to save time. Click on this ramp1 and say duplicate. And you see it automatically goes on the second register address space by default. So create 2 of these ramping tags. Now let's see what's happening in the quick client with these tags. Ramp2 is behaving normally because it has the address spaces enough. However, ramp1 overflows in register 2 here. So look what happens to ramp 1. It's all over the place. It overwrites itself over and over. So you might run into these type of conflicts. So how can we fix this? Can anyone tell me? How could we fix this conflict? There's 2 ways we could do it. Any ideas? Daniel, change RAM2 to RAM3. Well, let's say I do that. Change RAM2 to RAM3. That will not solve my issue, right? But I think what you meant is to move it to another register space, right? To register 1003. Yeah, yeah, I know. I'm just joking here. So yes, that would be a fix to make sure you write on the specific address spaces. So you have to take into account the data type and the size of the device. What's another fix? Another fix would be to change the actual settings of the device. It's an 8-bit device, but what happens if it's a 16-bit? If it's a 16-bit device, it means these two now have normal space. Because guys, let's say, what if you had 20 of these tags? Would you go individually and start, oh, okay, I have to put this to another register, and then I have to change this to another register? That's not very effective, is it? So it would be easier if you made this mistake to just change the actual device to 16-bit. So you won't have any conflicts in this way. Yeah. You see, they're all running smoothly. Okay. So that's just something to consider. So the last type of simulator driver we have is the memory-based simulator. However, we don't have any like specific demonstration here. Siddharth, you have a question there?
Yeah, I have query how you are launching this quick client so quickly. Is there any shortcut key for that?
Well, yeah, it's a trick of the fingers, Siddharth. It comes
Okay,
with practice, you know.
okay,
You get
okay.
very fast with the clicks. No, I'm just joking. No, it's you see there's this little icon here.
Yeah,
So I just rapidly click it, I jump to my channel, and voila.
okay,
And then I close it, and whenever I need it, I just move fast because I have practice. So
okay, okay.
yeah,
Understood.
fast fingers. Yeah, you know.
Thanks.
Yeah, I'm very familiar with the interface. So as you're gonna get familiar with it, you're gonna find these pretty natural to just move stuff here and operate stuff. It's a very simple interface, though. So this memory based is not that often used. There are some scenarios where you might use it, but it's specifically designed for Kepware to save data that does not change. So not much happening actually with this simulator. There are some use cases though, but we don't have any practical examples with it. So this is just another option. You can read more into the Kepware documentation webpage manual, or maybe they give you some examples there on how you might leverage this memory-based simulator. Okay. But the most important ones are those two. So I'm going to ask you here just to reinforce what we've done. Which of these 3 simulators creates a virtual device register with constant or function defined data. Which one of these three? The simulator. Yeah, the simulator driver. Let's say it by the full name. Yeah. So the simulator driver. And retains value that do not change. That's the memory based. Very well. And I think we have one final question here. Yeah. We have a scenario here. Which of these drivers allows you to simulate data that changes according to a function? Let's see. Closing the poll in 3. All right, these are some surprising results. I was expecting like a slam dunk. So only 6 out of 9 answered correctly, which is the simulator, C. Why the simulator? What does the advanced simulator do? What type of data it simulates? It simulates data from a data table entry via a CSV file or an ODBC database. So it's not actually according to a function. Functions are those ramping random functions that we've previously talked about. So the advanced simulator uses an ODBC data source and goes through the records. So that's it. It doesn't operate on a function. It just browses through records row by row like that automatically. Doesn't do anything else. Okay. Well, that was the hard part of this module. Now, very quickly now, up until now, guys, we've talked about device connectivity. So connection to devices, reading from devices, reading the tags. Now, let's go a bit over client connectivity. However, we're not going to go too deep into this section. We're going to leave this section for another class. So actually, in the curriculum, if we have a look in the catalog, except connecting with devices and Kepware server application, these classes deal with client connectivity. Yeah, so OPC clients, IIoT clients like REST and MQTT, ThingWorks, and even data loggers, external data loggers with database connectivity. So these classes will go more into the actual client connections. So I'm just going to go very quickly now and just explore what are these client connections, what are the plugins, what are their roles. So I've shown you this slide again in the very beginning. We have all these clients that can connect at once to the server. And you can see that these clients, some of them may use the same protocol, some of them may use a different protocol. See, you have an NES client on level 3 and an HMI on level 2 communicating under the same protocol, which is OPC UA. And then you have your other clients on different levels communicating with their own standards. That's fine. So Kepware will enable simultaneous access to client applications. These are the most popular standards in terms of client connectivity. Obviously, by far, the most popular and the biggest one is OPC. Yeah, OPC DA and UA. The UA is the latest one created by the OPC Foundation. This is what most modern industrial clients currently uses, the OPC UA. But we're going to discuss more about this in the actual OPC connectivity. Yeah. By the way, guys, like I said, OPC DA is the quick client. So the quick client we always launch to view data in Kepware uses it simulates an OPC DA. It's a real-time connection. Yeah. And then you have the other standards, like always on, it's specific standard to ThingWorx, which is another PTC product. We're going to learn more about it in the IIoT course. Then you have REST and MQTT, which are connectivity options spanning from the plugin called IoT Gateway. So there's a plugin here in Kepware called IoT Gateway. This leverages those two connections, REST and MQTT. Will be talked about in more depth in an IoT class. You can also write data out to a database using the ODBC connectivity. This is leveraging the data logger plugin. Again, all of these guys will be covered in classes in future courses. Just trying to show you what we're going to discuss in other classes. Now, there's two main types of connections that the client uses. We are either an interface client, a native interface, or advanced plugin connections. So for OPC and real-time and native interface, the settings for these connections are configured within the project properties. What do I mean? So the project properties, guys, right here in the project, if you check the properties, you have here on the left, these are what we call the native client interfaces. So these interfaces can be configured and enabled from here directly. Most of them are disabled, obviously. We don't have an OPC client connected, but you can enable these here, like enable OPC AE. Yeah, if you have an AE connection incoming. ThingWorx, again, you see the interface can be handled here. The connection settings can be set here directly into the interface. The other clients come through plugins. So these are extras that are being installed in Kepware. We call them advanced plugins. So this is for the other types of clients, like REST and MQTT communication, like I said, via the IoT gateway. Data loggers, so connection to an ODBC data source, schedulers, historians, or OPC HDA, basically. DDE, DDE is actually it's an actual native interface. It's Microsoft Dynamic Data Exchange. Yeah, this is primarily used for Microsoft Excel. So all these clients that we call them internal clients, either through the interface or drivers, have the ability to read and even write data to or from the connected devices. And we can actually request this connected device to do something else. So internal clients is what we refer to all the clients coming directly from the native interface or the clients coming from drivers or clients coming from the actual advanced plugins. These are all internal clients, we call them. They all have this ability to read data from Kepware and write data. Yeah, so these are the clients here at the top that will connect to Kepware via plugins. Now, there are other plugins here which are not actually necessarily an internal. They are internal clients, like Advanced Tags, for example, is a type of internal client. However, it's not connected to an external client application. It has its use only within Kepware, but we have a whole class designated to Advanced Tags plugins. So don't worry, all of these, most of these will be going to much more depth for this class. We're going to end right here with the client connectivity. We're not going to go any deeper than this. We've covered basically the basics of device connectivity and client connectivity. So do you have any questions that I need to go through here?
What are aliases? Like, why? What is the purpose of this?
It's another type of plugin specific to certain scenarios. We will address the alias in another class, aliases. Okay. They're also used in ThingWorks. Aliases can be used in ThingWorks with ThingWorks to make a reference in to another channel. You're gonna see as we get to it.
Sure. Thank you.
And we have a question in the chat from Edgar. How long will the test environment be available to us? Well, Edgar, for as long as this class goes, and even 30 minutes after. So after we end the class, after I end this course, I mean, you still have another 30 minutes to play around. However, that's it. It will not run any longer than that. So the only way you get access to the virtual machines are during the instructor classes. And I had people also asking me like, hey, Gabriel, how can we get more, more instructions, more tutorials, or more work, more value? Well, thankfully, we have this nice little learning platform. It's called PTC Learning Connector. I'm going to share with you the link. Actually, I'm going to browse through it just now. So this is the link. So if you go to this link, guys, you select the product that you want to look for. Let's say I'm looking for IoT. Yeah, I'm looking for a Kepware server related, and what type of category you're looking at. Let's say fundamentals, and you have here tutorials list for related to Kepware fundamentals. Let's see all the tutorials. All of these are tutorials, guys, which further give you some more training material, like the client interface training, integrate Kepware with ThingWorks training, the API. All of these we do in the classes, but you can further, go and take these tutorials. Yeah, you see, you have like these nice little explanations here. So this is just something extra that you can explore outside of the course content. And I think we also have like playlists here. Yeah. Like a playlist that you have to go through, like, okay, you go through this entire playlist to get accustomed to the fundamentals of Kepware. And you have this for all the courses here, all the products that we offer. Okay, so this is a very nice little web page here, very intuitive. You can search for your classes here. You can see certification exams here. Yeah. You can even filter, like if you want to find future classes of Kepware. And you can even, if you like me, guys, and I'm not going to ask you, but you can leave a feedback. You can actually search for my name. And if only I could find myself. Oh, there you are. And say, hey, I really like Gabriel's class. I would like to see him again. So I'm just going to check Gabriel's classes and I'm going to enroll to them, right? Or whatever time suits you. Okay, so again, this is a very intuitive interface here. Another question from Rodriguez in the chat. These classes are not recorded. And I would also ask you to not attempt to record these classes either. It's intellectual property of PTC. So it's illegal to record these classes. That's what I have to say about this. You do have access to my PowerPoint slides, however. So if you check this, when you check the class day portal, when you enter the class here, you can see on step number 3, you have access to the class materials. So the student guide, it's called. It opens up the PDF of my slide. So you can review what we've discussed today. Okay. These will remain available for approximately a year after you finish this class. Yep. And you have here all my slides. Yep. That's all the help I can give you. What type of questions comes in the Kepware Associate exam? Good question. Let me filter. Where is it? Kepware Associate Certification exam. This has been recently restructured, remade, the 2023 exam. It also contains practical questions. You also have a study guide here for this exam, just so you know what you should, some questions here, like what is the associate exam, what is the curriculum you need to study. And it's a practical exam, guys, by the way. Here, read this. Its practical exams consist of random questions based on the use cases we have in our courses, but you're also going to receive lab files with a virtual machine, and you have to execute those tasks in the virtual machine to get the points for the question. So for the duration of the exam, for 3 hours, you're going to get access to the virtual machine. So you guys can take some practical questions there, because there's some of them will be practical. So it's a fun exam, in my opinion. It's not very difficult. So please do check the Learning Connector link I've provided in the chat. You're going to have lots of information here to find out. Well, guys, I'm not going to keep you any longer. I do hope you enjoyed the class today. If you loved it, please click that link in the chat. Give me a feedback. Let me know how I did. If you like my style, if you like my accent, if you enjoyed and if you learned some valuable information, please let me know there. I would appreciate a feedback on you guys. So I'm going to see you next time for the next course in Kepware. All the best of luck. Have a great evening. Thank you, Siddharth. Thank you for the nice words. Thank you, Anna. Thank you all. See you next time.